Basics of COP, that is coefficient of performance. In this video, I am going to explain you the COP of refrigerator, heat pumps, and thermal efficiency of heat engine. COP is the ratio of desired thermal effect to the work input. Higher the COP indicates more efficient system. Now consider the heat engine. The purpose of heat engine is to perform work. COP is not directly applicable to heat engine, but the measure of efficiency is the thermal efficiency of heat engine. In heat engine, the heat engine absorbs the heat from the hot body and converts it into mechanical work, which may be used for driving the shaft. The rest portion of the heat is then transferred to the cold body. The work performed because of the exchange of heat in the heat engine is WE, that is nothing but H2 minus H1, that is the difference between the enthalpies of hot body and cold body. WE is equal to H2 minus H1 is equal to enthalpy of hot body minus enthalpy of cold body. The thermal efficiency is the work done, that is the output of the desired thermal effect upon the heat supplied. Why it is work done upon heat supplied? In the numerator, the work done comes because the purpose of heat engine is to perform work. Thermal efficiency will be WE upon H2, that is nothing but H2 minus H1 upon H2. Now coming to the refrigerator. The purpose of refrigerator is to extract the heat from the cold body. We require work input be given to the refrigerator, that is WR. As we give input to the work to the refrigerator, it extracts the heat from the cold body, that is the refrigerator, and further cools it and and transfers the heat to the surrounding, that is the ambient temperature outside. The work input that is required for refrigerator is also the difference between the two enthalpies, that is the enthalpy of hot body H2 minus the enthalpy of the cold body H1. The coefficient of performance of refrigerator is heat extracted, that is the desired thermal effect upon the work required. Purpose of refrigerator is to extract heat from the cold body. That is why it comes in the numerator. COP of refrigeration will be H1 upon WR. WR is nothing but it is H2 minus H1. So COP of refrigerator is H1 upon H2 minus H1. Now consider the heat pump. The purpose of heat pump is to supply heat to the hot body. That is, it is used to heat the homes. This also requires work input, that is WP. The mechanical energy is converted into thermal energy. It will supply the heat from the ambient temperature or the cold body to the hot body in this way. The work input that is required is also the difference between the enthalpies of hot body minus the enthalpy of the cold body, that is H2 minus H1. So the coefficient of performance will be heat supplied in the numerator, which is the desired thermal effect upon the work required. That is COP of heat pump is heat supplied upon work required. Heat supplied is nothing but it is H2, and work required is WP. So the COP of heat pump will be H2 upon WP. WP is nothing but it is the difference between the two enthalpies, that is H2 minus H1. So the COP comes out to be H2 upon H2 minus H1. Further calculating H2 upon H2 minus H1 will give you H1 upon H2 minus H1 plus 1, that is coefficient of performance of heat pump is equal to the coefficient of performance of refrigerator plus 1. COP of heat pump is equal to COP of refrigerator plus 1. Thank you.